Hello everybody, today's video is on simplifying expressions and factoring. A couple of vocabulary things that we need to know are like terms. Like terms are things that can be combined through addition and subtraction. Okay, so if I say 2 plus 3, that can be combined to be 5. So 2 and 3 are like terms. Other like terms that go with 2 and 3, 2, 3, 7, -15, 2/3, all these things are like terms with each other. Now, if we have a variable like an x, or 2x, or 5x, or -2x, or 2/3 x, these all have an x in them, so these are also like terms and can be combined through addition or subtraction. So if I said 5x minus 2x, that would equal 5 minus 2 is 3, so that would equal 3x. It's like saying you have 5 basketballs and someone takes away 2 basketballs, you still have 3 basketballs left. The variable has to be the same, so if there's something with a y, that wouldn't work for the red or the purple here, so the y would be its own. So we could use y, or 2y, or -18y. So the blues all could be combined with addition or subtraction. The reds can all be combined with addition or subtraction. The purples can all be combined, but you cannot combine, for instance, an x and a y, or a y and a 3, or a 2y and a 2. Okay, those are all, because those are unlike terms. So it has to have the same variable or no variable at all. So if we had 2y plus 18y, we would get 20y. Now, coefficient is the number in front of the variable. So 2 is the coefficient of 2y. 18 is the coefficient of 18y. It's the number that is being multiplied to the variable. Okay? All right. So first of all, we want to learn how to simplify expressions like this. So it has variables and things with not variables. So this has 4 terms. 1, 2, 3, 4. And those terms can be moved around any way we want, so that we can get the x's together and the things without an x together. So if we say like this 5x can be combined with this 2x, and this 4 minus 4 can be combined with this plus 9. So we're allowed to move stuff around as long as we keep the sign that goes with it. So I've color coded this one to make it easier, but obviously the problems you're going to be working on are going to be color coded, so there's a simple rule to follow. The sign, so this minus sign after the 5x, goes with the next number to the right. So this minus has nothing to do with the 5x. It has only something to do with the 4. We're going to subtract 4. This plus only has something to do with this 2x, and this plus here has only something to do with the 9. So when we move things around, either in our heads or on paper, we have to make sure to carry the sign along with it. Now I could have put this -4 here first, but I think 9 minus 4 makes more sense often than -4 plus 9. So once we put things in that order, it's pretty simple. 5x plus 2x is going to equal 7x, and then 9 minus 4 is a positive 5, so we put a plus 5. Now if we were to move around this stuff so that the 5x was not in the beginning, like for instance, let's say we wanted the 2x here, now this would mean multiplication, which we don't want. So here, whenever a number is the first number, if it's positive, it's just assumed that way. You don't put the plus, but if we want to move it somewhere else, we have to make sure we put a plus in there with it. So this would be the same answer. We have a 2x, and then you wouldn't need this addition sign here. So we still would get 7x plus 5. Let's see, so here we have a similar situation where we have 10r minus 5 plus 3 minus r, and then we want to combine these r terms, so we can rewrite it if we want to look like 10r minus r minus 5 plus 3. And when you have a letter that does not have a coefficient on it, it technically does have a coefficient, but just like we don't put the plus sign here, we don't put the 1 here. It's actually like an invisible 1. So you can think of this as actually being, I'll put it in a minute, so I'm going to change the color. So you can think of this as being a 1 right here. A lot of people, when they look at this, think 10r minus r is just 10. Okay, that would be an incorrect assumption. What you're really doing is 10 minus 1 and then putting an r on the end of it. So it's actually 9r. And then a negative 5 plus 3 we know is negative 2, so we just call that a minus 2. So remember, that sign has a lot of different meanings. It means subtract, it means opposite, it means negative, and oftentimes those can be used together. So a negative 5 plus 3 is a negative 2, but when you put that negative 2 down here, it just makes it a minus 2. Okay, let's try something like this. Okay, here we have another simplified problem. We want to simplify this, but there's some distributive property going on, meaning this 6 has to be multiplied to everything in here. And so we can't combine any like terms like the 6 and the 3 and the minus 4 until we deal with this multiplication. So using the distributive property, we're going to have multiply to both. So 6 times 2 is 12, and then times x. So we have 12x, and then 6 times positive 3 is 18. So plus 18 minus 4. Remember, this 4 is not affected by the 6 because the parentheses end here at the 3. So now we just combine like terms. 12x is all by itself, and then 18 minus 4 is positive 14. Now that same thing works with fractions. Now don't be scared just because there's a fraction here. The same thing works. We still use the distributive property to multiply this times this. So the 2/3 is going to first multiply times 12y. Well, you guys are used to using fractions to multiply with fractions, so we can do that. We have 2/3 times 9/1, and then we have this plus 4 here. So all I've done is written it such that the 2/3 is multiplied to each thing individually. Once you write it out like that, it's pretty simple. 12/3 is 4. You get this 3/9. And so you end up with 4 times 2, so 8 times this y here, plus, and we have 2 times 3, so 6, and then this plus 4, which wasn't affected. And then we combine these final like terms here. So 8y plus 10. The factoring is a little different, and it's actually the opposite of the distributive property. I'll show you. What you're going to do is figure out, you look at these two terms, and you want to figure out what do they have in common. If we were to factor them, what are their greatest common factors? So 4 is 2 and 2, and then 14 is 2 and 7. So the greatest thing they have in common is a 2. So if we factor out 2, the remaining part here would be a 2, but there's still an x there, and then a 7. And so this is what factoring is. You start with this green one and you turn it into this. You can see it's the opposite of the distributive property, because distributing would give you 4x plus 14. So it's the opposite of that. Now, when you're factoring something like this, where the greatest common factor is that whole number, right? 6 is the greatest common factor here. When you factor out the 6, you get 2y minus, and then it's not that it goes away, it's actually dividing out. essentially you're saying 12 divided by 6 is 2, and then 6 divided by 6 is 1. And you can check that by using the distributive property on it here to see if it worked. 12y minus 6. Okay, so here would be the final answer if the instructions asked you to factor, which you'll be practicing tomorrow.